Before we move on to domain and range, first we need to kind of review how we can write sets of information. So there's two different ways we're going to look at in this course. One is called interval notation. One is called set or set builder notation. Now, interval notation for domain and range is oftentimes the easiest because we're describing over some interval where our x and y values are. And so interval notation uses a combination of parentheses and brackets to describe some interval. So interval notation means that parentheses in interval notation would mean that we have a value that is not equal to. So this would be used if there were a greater than or a less than. We also use parentheses anytime we're describing infinity. Now you're maybe thinking, why do I need to know infinity and negative infinity? Well, if our graph continues forever, then we describe forever using infinity or negative infinity, depending on which direction it's going. Now, the only time we pick up brackets is if there is an equal to, if points are included. Okay, if points are included, then we're going to use brackets. So, for example, if I have the inequality, x is greater than or equal to 4. X is greater than or equal to 4 means that we're going to start at 4, which is included because of the equal to, and we would go on forever. That means the interval notation for that would be bracket 4, because we started at 4, and then we would go to infinity, and that would be a parenthesis. So we can have a combination of brackets and parentheses based on what we're trying to describe. If I want to describe all real numbers, because maybe it covers the entire number line, then we're going to put parentheses negative infinity to positive infinity. Now understand, negative infinity should always be on your left because negative infinity means you're going left forever. And positive infinity should always be on the right because that means you're going right forever. Okay? So just know that we're just going to pick parentheses or brackets, and as I go through examples, I will be writing interval notation to help you with that. Now, set builder notation is using the curly braces to build a set. And so when we're writing this, we're going to do x, which is my variable. This is always going to be the variable. If the variable is not x, then we might want to just change that. Then I'm always going to have a bar. And then this is going to be a description of what I am using. So what my x values are. So in that same problem, x is greater than or equal to 4. For set builder notation, I would curly brace x because my variable is x, bar, and then if my description is x is greater than or equal to 0, then that, or greater than or equal to 4, that's what I'm going to put there. Okay, so all real numbers here is a little different because we actually have a symbol that means all real numbers. So we would say x, then we would do almost like an E, and then you would do the symbol for all real numbers. Okay, so let me just tell you that the mathematics has its own symbolism, just like learning any other language. So we would read this as the set of all x values such that x is real. That's how I would read that. This one right here, I would say the set x such that x is greater than or equal to 4. So with the set builder notation, we're writing a sentence to describe a solution set. With interval notation, we're using shortcut symbols to describe an interval. Okay? Set builder notation is a little bit more flexible in how you describe things. Interval notation is a quicker way to write intervals no matter what they are. So let's look at some examples so we can kind of build on this knowledge. So domain, remember, is x, range is y. One way that you can do this is with highlighters. So I'm going to highlight my x in yellow. Okay, and then I'm going to look on the left because x is left to right. So on the left side of my graph, I have an arrow that points up or points to the right, left, and then I have an arrow that points to the right. also in this case going up, but I'm looking really, when I'm looking at domain, I'm looking left, right. Left, right, both sides have an arrow. What that means is that my domain here is going to be all real numbers, which in interval notation is negative infinity to positive infinity. If I want to write that in set builder notation, then I would write it as bracket x such that x is real. Okay? Now, the range is going to be a little different. The range is my y values. So I have to look at my lowest y and my highest y. Well, my lowest y is right here at positive 2, but my highest y is arrows. That means I'm going to start at 2, but I'm going to go up forever. And so interval notation wise, I would start with a bracket 2, and then I would go to infinity. In set builder notation, that is x. Nope, not x. Let's fix that. Okay, that's y, because I'm dealing with y here, such that y is greater than or equal to 2, because it starts at 2 and goes up forever. So let's look at number 18. So I'm going left to right for domain. Left to right for domain. So left, if you look here, left has an arrow. Right has an arrow. Look in between. Do we skip any x values? On this x, if I look, can I find x values everywhere? And in this case, I actually can. So the domain is still going to be all real numbers. Okay? The range goes from bottom to top. So if I look, my lowest y value is down here at negative 10. When I go up, my highest, I've got arrows pointing up here. And do I skip any y values? Well, if I look and I fill this in, I see that I don't actually skip any y values anywhere. So that means my range is going to be from negative 10 to infinity. Let's do a couple more. So let's look at number 19. Well, when we look at it, my domain, I'm looking x to y. I have an arrow over here. I'm going to look, and over here, I actually have an endpoint over here. There's not an arrow on the right, so I'm going to have an endpoint. That value is 4. So my highest x value is 4, but I have an arrow pointing to the left. So on the left, it's going to negative infinity. But on the right, I'm stopping at 4. And if I look, I don't actually skip any x values there, but I end my graph at 4. So it's not all real numbers on that one. When I do my y's, this is my lowest y value right here. That's at 1. My highest y value, actually, my highest y value is up here at 8. So I'm 1 to 8. However, notice what happens right in here. There are no y values. There's not a graph between 1 and 2. There's not any graph on the y values of 1 to 2. So how do I write that? Well, I write that as I've got the value 1, so I'm going to use set there. And then I'm going to do what we call union that. It's just a capital U. With the interval that starts at 2 and ends, almost wrote infinity, that's wrong. It ends at 8. But both of those are included. So let's look at this last one. The domain, my x's, has a definite starting point here. And as I go across, I notice that the right-hand side has an arrow. Means it's going to keep going. So for our domain, I have a definite starting point of -2. But I do not have a stopping point because that's an arrow, so it's going to go to infinity. Then for my y values, I see that I have the starting point here at -1. I have a high point up here at 1, 2, 3, 4. Let's write that down. But notice what happens over here on the right-hand side. I'm actually pointing down forever. So this is actually not my lowest point. I'm actually going to go to -infinity. And remember what I said, we always put -infinity on the left. Then my highest point is at 4. The graph goes through that, so I'm going to put a brace.